The National Electrical Code, or NEC, does not specifically address the use of a phase converter on the supply side of a fire pump controller. However, several general requirements within the code apply. Firstly, NEC Section 695.9e mandates that fire pumps must be powered by a reliable electrical source. Secondly, Section 695.11 requires a fire pump to be supplied by a service that is separate from the building's normal electrical supply. Thirdly, NEC Section 695.12 requires that the fire pump be connected to a power source that is capable of maintaining the pump's required pressure and flow rate. Additionally, NEC Section 450.2b dictates that transformers must be installed and used in accordance with the manufacturer's instructions. Also, NEC Section 450.4 requires transformers to be protected from overcurrent and short circuits. Furthermore, NEC Section 250.8 requires that electrical equipment be grounded to prevent electric shock, and NEC Section 250.110 specifically requires transformers to be grounded. Based on these NEC requirements, using a phase converter on the supply side of a fire pump controller may be permissible if the following conditions are met. 1. The phase converter must be appropriately sized and installed according to the manufacturer's provided instructions. 2. The phase converter should have adequate protection against overcurrent and short-circuit events. 3. Grounding of the phase converter must conform to NEC Section 250 stipulations. 4. The fire pump should be connected to the phase converter following the guidelines of NEC Section 450. 5. Testing and certification of the entire fire pump system is crucial to verify its ability to maintain the necessary pressure and flow rate. Given these considerations, it's highly recommended to engage a qualified electrical engineer to design and install the phase converter system. This ensures that the system complies with all relevant NEC stipulations, guarantees a fire pump system's reliability, and maintains a high level of safety. For the specific situation involving a 600 amp 240 volt single-phase service and a 40 horsepower 480 volt three-phase fire pump motor, the phase converter must not only convert single-phase to three-phase power, but also step up the voltage from 240 volts to 480 volts. This dual function adds complexity to the system. Carefully select a phase converter that is designed for both voltage transformation and phase conversion, ensuring it can handle the fire pump motor's load requirement. The sizing of the phase converter is paramount. It must be capable of supplying the fire pump motor's full load amps plus any additional load imposed during motor starting. The manufacturer's specifications for the fire pump motor will provide the necessary information for calculating the appropriate phase converter size. Typically, a rotary phase converter is preferred for fire pump applications due to its ability to handle high inrush currents during motor starting. Static phase converters may not be suitable for this application, as they often cannot provide sufficient starting torque for larger motors. Overcurrent protection is essential to protect the phase converter and the fire pump motor from damage due to faults or overloads. The overcurrent protection devices, such as fuses or circuit breakers, should be sized in accordance with NEC Section 430, which covers motor circuits and overload protection. The phase converter's input and output circuits must have appropriately sized overcurrent protection. Grounding is crucial for safety and to prevent electrical shock hazards. The phase converter and all associated equipment must be properly grounded in accordance with NEC Section 250. This includes grounding the equipment grounding conductor to the building's grounding electrode system. A separate equipment grounding conductor must be run with the circuit conductors to the fire pump motor. The wiring methods used to connect the phase converter to the power source and to the fire pump motor must comply with the NEC. Typically, rigid metal conduit, intermediate metal conduit, or electrical metallic tubing are used for fire pump circuits to provide physical protection and ensure a reliable ground path. Flexible metal conduit may be used in short lengths where necessary for vibration isolation or ease of installation, but it must be properly grounded. A transfer switch may be required to automatically switch the fire pump to an alternate power source in the event of a power failure. The transfer switch must be listed for fire pump service and comply with NEC Section 695. The transfer switch must be capable of transferring the fire pump load without interruption to ensure continuous operation. The fire pump controller must be listed for fire pump service and comply with NEC Section 695. The controller provides the necessary control and protection functions for the fire pump motor, including starting, stopping, and monitoring. The controller must be located in a protected location and be accessible for maintenance and testing. Regular testing and maintenance of the fire pump system are essential to ensure its reliability and proper operation. The NEC requires periodic testing of the fire pump system to verify its ability to meet the required pressure and flow rate. Maintenance should include inspecting and testing all components of the system, including the phase converter, motor, controller, and wiring. Documentation of the fire pump system is crucial for future reference and maintenance. Complete documentation should include wiring diagrams, equipment specifications, test reports, and maintenance records. This documentation should be readily available for inspection and maintenance personnel. Because the phase converter installation involves both phase conversion and voltage transformation, it is important to ensure that all equipment is compatible and properly coordinated. The phase converter must be capable of handling the voltage and current requirements of the fire pump motor. The wiring and overcurrent protection must be sized accordingly. Coordination between the phase converter, motor, and controller is essential for reliable operation. The authority having jurisdiction, or OJ, will have the final say in whether the proposed installation is acceptable. It is essential to consult with the AHJ early in the design process to ensure that all requirements are met. The AHJ may have additional requirements or interpretations of the NEC that must be followed. Obtaining approval from the AHJ before commencing the installation can prevent costly rework and delays. Consider the environment in which the phase converter and fire pump equipment will be installed. The equipment must be protected from moisture, dust, and other environmental factors that could affect its performance. Enclosures should be rated for the environment in which they are installed. Temperature is also a consideration, as extreme temperatures can affect the performance of electrical equipment. Proper ventilation or cooling may be required to maintain the equipment within its operating temperature range. The NEC requires that all electrical equipment be listed by a recognized testing laboratory, such as Underwriters Laboratories, or ALL. Listing ensures that the equipment has been tested and meets safety standards. The phase converter, fire pump motor, controller, and other components must be listed for their intended use. Documentation of the listing should be provided to the AHJ for approval. The installation of a phase converter for a fire pump system can be complex and requires careful consideration of all applicable codes and standards. Engaging a qualified electrical engineer and consulting with the AHJ are essential steps in ensuring a safe and reliable installation. Proper design, installation, and maintenance are crucial for the fire pump system's ability to perform its intended function. In addition to the NEC, other codes and standards may apply to the installation of a phase converter for a fire pump system. These may include local building codes, fire codes, and insurance requirements. It is important to be aware of all applicable requirements and to ensure that the installation complies with all of them. The fire pump system is a critical life safety system, and its reliability is of utmost importance. The design and installation of the system must be carefully considered to ensure that it will operate reliably in the event of a fire. Regular testing and maintenance are essential to verify the system's performance and to identify and correct any potential problems. The cost of installing a phase converter for a fire pump system can vary depending on several factors, including the size of the motor, the complexity of the installation, and the local labor rates. It is important to obtain accurate cost estimates from qualified contractors before commencing the installation. The cost of the phase converter itself can range from several $1,000s to tens of thousands of dollars, depending on its size and features. The cost of the installation will depend on the amount of labor and materials required. Ongoing maintenance costs should also be considered. The phase converter should be inspected and tested regularly to ensure that it is operating properly. Any necessary repairs or replacement should be performed promptly to prevent problems. A potential alternative to using a phase converter is to install a new three-phase service to the building. This may be a more expensive option, but it would eliminate the need for a phase converter and could provide a more reliable power source for the fire pump. The decision of whether to install a phase converter or a new three-phase service will depend on several factors, including the cost, the available power, and the reliability requirements. The voltage drop in the circuit supplying the fire pump motor must be considered. The NEC limits the voltage drop to 15% under motor starting conditions and 5% under normal running conditions. The voltage drop must be calculated to ensure that it is within the allowable limits. The size of the conductors must be increased if necessary to reduce the voltage drop. The impedance of the phase converter must be considered when calculating the voltage drop. The phase converter's impedance can contribute to the overall voltage drop in the circuit. The phase converter manufacturer can provide information on the impedance of their products. The power quality of the single-phase service supplying the phase converter must be considered. Voltage fluctuations, harmonics, and other power quality problems can affect the performance of the phase converter and the fire pump motor. Power conditioning equipment may be required to improve the power quality. The phase converter manufacturer can provide recommendations on power conditioning equipment. A surge protective device, or SPD, should be installed to protect the phase converter and the fire pump motor from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. The SPD should be sized and installed in accordance with NEC Section 285. The SPD should be located as close as possible to the equipment it is protecting. If the single-phase service is not large enough to supply the phase converter and the fire pump motor, the service may need to be upgraded. The size of the service will depend on the load requirements of the phase converter and the fire pump motor. The local utility company can provide information on the available service capacity. The decision of whether to upgrade the service will depend on the cost and the availability of power. The fire pump motor must be protected from overload. Overload protection can be provided by an overload relay in the fire pump controller. The overload relay should be sized in accordance with NEC Section 430. The overload relay should be set to trip at a current level that is slightly above the motor's full load amps. The fire pump motor must be protected from short circuits. Short circuit protection can be provided by fuses or circuit breakers. The fuses or circuit breakers should be sized in accordance with NEC Section 430. The fuses or circuit breakers should be sized to protect the motor and the wiring from damage due to short circuits. The location of the phase converter should be carefully considered. The phase converter should be located in a clean, dry, and well-ventilated area. The phase converter should be protected from physical damage. The phase converter should be accessible for maintenance and testing. The phase converter should be located as close as possible to the fire pump motor to minimize the length of the conductors.